Greetings all. Tonight we're going after the Oyster Nebula. Now the Oyster Nebula is a planetary nebula out in the constellation of Camelopardalis. Where that's at, it's just to the left of the squash leg of Cassiopeia. It's out near the Heart and the Soul Nebula. Now the Oyster Nebula is about 4,240 light years away from Earth, so that makes it, about 1.3 parsecs. Now this is a dying star, and the dying star, it's in the latter stage of its life. It's already poofed off its outer layers of atmosphere and dust. So you got this cloud of gas expanding that the star poofed off, and it has exposed its core, which is a really bright carbon-rich Wolf-Rayet star that is radiating this cloud of gas, causing it to fluoresce and emit, thus giving us the Oyster Nebula. Now, if you think I'm filming this intro to the Oyster Nebula from my pool deck in Central Florida, then you would be incorrect. Actually, I'm filming this coming to you from some place called Vancouver in British Columbia or something or other like that. But anyhow, you may not believe this, but this is true. Right behind me, look right over here. There's Luthor Corp Plaza and the Daily Planet. Can you believe that? Luthor Corp Plaza, Daily Planet, right there. So I'm bringing you the Oyster Nebula from the Luthor Corp Plaza and the Daily Planet. Greetings all. Tonight we're going after the Oyster Nebula out in the constellation of Camelopardalis. Now Camelopardalis, it sounds like a camel. The stars are all named Camel. Camel this, Camel that, Camel the other. So you might think that that's a camel constellation, but it's not. They call it the giraffe. Go figure. Anyhow, I don't name them, I just take their picture. But we got an oyster and a camel out in a giraffe. So talk about astro animals. Talking about astro animals, I got a monkey on my trail camera the other day. Can you believe that? A monkey. And you probably don't believe it, so I'm going to show you its picture. I was looking through my pictures. I was hoping to get something different than the deers and the coons and the squirrels and the possums and skunks and armadillos and all that stuff. Maybe a panther, a bobcat, a bear, or a coyote. And then all of a sudden there was a monkey. There he is right there, the monkey, right over by my corn feeder. Anyhow, this is the rig we're using tonight. You see this, the Celestron Edge HD11. I got my big old 2-inch image train on the back. And one thing I'll point out, but because this object is so small and so far away, notice that I don't have a focal reducer on there. So I'm shooting at native focal length. I'm going for the full 2800 millimeter native focal length. So no focal reducer. I don't know how that's going to work. Never tried it before, but we'll learn together. Anyhow, that's what we're using, the ASI 1600 mm Pro dedicated astronomy monochrome camera. Hooked up to my ZWO 7-position filter wheel. Camera rotator right there, some spacers. There's the 2-inch Celestron auto guider, and got my Starlight Express X2 guide camera in there. So that's our rig. Of course, I got my dew heaters down there, 3 dew heaters now, and in the 4th dew heater spot, let me show you what I got. I've got this dew heater ring there. You see that ring that holds on the corrector plate? That one right there? That's a dew heater. See it right there? And it just plugs in by those wires right there. Just plugs in right down there to one of my dew heater slots. So that ring just puts heat right directly on the glass. And believe me, I need it out here in Central Florida, because if I don't have this dew control equipment, my lens is dews up and I'm done for the night. Now let me show you one other unfortunate thing that happened. Look down here. My mount had a structural failure. See this right here? Right now this looks like a clump of wires and stuff, which it kind of is, but I had it hanging right up here with some Velcro, some sticky Velcro. See how it just hangs on there? And the sticky came off and it just collapsed down into the void there. So my wife and my mother were kind enough to get me some more sticky Velcro. So I'm going to make that repair before it gets dark. Correct the structural failure that my mount had, and then we'll be ready to go. Okay, here we sit getting ready to go on the Oyster Nebula. I have already got polar aligned. Right now we are sitting with the scope pointed back up to the north celestial pole. There it is right there. You see you got the big old edge HD11. That's what we're shooting the Oyster Nebula with tonight. But you can see it's pointed back up to the north there. You can also see in the background and get some clouds out there. So I can't get started just yet. Got to wait on those clouds to clear out. But the weather guessers are saying maybe another hour and it's going to clear right on up. Clear outside says the same thing. So I'm counting on that fact. Anyhow, there it is, the big edge HD11 pointed up to the North Pole right after polar alignment, waiting on the clouds. So I showed you what that looks like pointed up to the North Pole there. Well, what we're going to do, here's the blue Oyster Nebula under this pulsating box here. And if you look over here, I want to show you one thing. Notice the telescope. I've got the Edge HD11, but look down here at my focal reducer. None. So I'm shooting tonight the blue Oyster Nebula at native focal length of 2800 millimeters. I've not tried this before, so I'm not sure how it's going to work, but we're going to give it a shot. And you'll see in a second why I want to go native focal length of 2800 and not put the focal reducer on it. Let me show you that right now. Here's the blue Oyster Nebula. Let me get it around here under the middle. When I zoom in on it, you see this red stuff? That's how we're going to be framed up. That's what the camera's going to see. And you see we have to zoom way in here to see it. It's a little old bitty target. But there it is. You got to zoom way in here to see it. So anyhow, that's why I want to shoot with 2800 millimeters instead of using my 0.7 focal reducer, which would give me 1960. So that's we're going to give it a shot and see if we can get that done. Anyhow, that's what it looks like, the blue Oyster Nebula. All right, while we're waiting on the clouds to clear up, let me show you what we're going to do. As soon as we get started, we're going to move over here to this star Capella. It's pretty much straight over my head right now. It's just a little past the meridian, but it's out there kind of close to the Oyster Nebula. We're going to go out here to Capella, get focused, do our synchronization. I will probably also, we might go ahead and do our auto guide or calibration there. We might not. But I'm not going to have to rotate the camera, because you saw this target is so small in the frame that it really doesn't matter which way the camera's oriented. So I'm not even going to worry about rotating the camera. So we get on Capella, we'll get focused, we'll do our auto guide calibration, and then we'll be ready to get right on down to the Oyster Nebula and start taking pictures. Let me show you what that's going to look like. Earlier today I built a I built a targeting plan for the Camel's Eye Nebula. That's what Neener thinks it is too. Neener thinks it's Camel's Eye Nebula, so maybe it is, but I think it's Oyster Nebula. But anyhow, this is the imaging plan that we're going to do. And notice that I'm going, let me get up to the top. Here I'm going 10 minutes, that's 600 seconds. That means 10 minutes of HA, 10 minutes of O3. I'm going to do 2 each. Just take a quick peek at what those look like, and assuming they're good, then we're going to shoot some broadbands, some red, green, and blue. I'm going to do 60 seconds, so 1 minute on each of those, and I'm going to take 20. Now this is going to be just to get the natural star colors that are bug. I ate a bug. This is just to get the natural star colors that are out there around the Oyster Nebula. And then we're back to shooting the HA and O3. And right now, you see if we started right now, it would finish up at midnight 53. That's too long, but I'm not going to adjust it until we get going. And I'll knock some of these exposures off the end to finish up at midnight 30. Anyhow, here's the plan that we're going to be using. Oh, and I almost didn't turn dither on. That would have been a disaster right there. I'm standing out in my driveway out in the front of my house looking back to the east. You see there's still clouds back there. The moon just came up. But look back here to the southeast. You see it's starting to clear out back here. And the clouds are moving from east to west, so I think they're on the way out. This whole part of the sky back here is clear back to the southeast, and it's moving east to west. So I think just maybe another half hour, 45 minutes, and we're going to be ready to get going. I have this night mode on my camera, so I'm trying to use it without my light and see if we can tell what's going on. But there's a telescope pointed up to the North Pole. I'm going to hit slew, and there it goes, heading on towards Capella, just like we told it to do. I can tell you it is going in the right direction to point at Capella. Okay. So there it goes, right up, pointed towards Capella. Let me show you Capella up in the night sky. See if you can. That's it right there. That's Capella. It's almost straight overhead. That's it. That's where the telescope is trying to look at. Now there goes an airplane past Capella. Yeah, but that's where we're pointed at right now. Okay, baton mask is on. And you can see that we're close to focus, but not focused. So we need to get the center spike right here to get right in the middle of those X's. So I'm going to go and make a change to the focus and tighten this focus up. All right, I turned it clockwise that time. I think I made it a little better, but still not good enough. I'm going to turn it some more in that same direction clockwise. That's a total guess which way to go with the focus knob, but it looks like that was the right direction. And I got to tell you, I think that's it. That's focus right there. You see how the center spike, now notice that this one is a little bit off to the side, but these ones over here are dead in the center. And the reason that is because of that view heater plug-in that I showed you. My baton mask sits a little bit cockeyed in there, so it makes one or two of those spikes look a little bit off when the others are right on. Anyhow, this is focused, so we're good. I'll take the baton mask off, and we'll be ready to keep going. Now, I'll mention that I was fooling around with this setup last night. I didn't get any pictures because the weather, it was too cloudy. I was fooling around with the setup, And I did get the guide camera focused with the scope, so that's why I don't have to fool around with it now. That's how come the guide scope was automatically focused, because I was fooling with it last night. And plate solving did not work at all last night, but that's because it was cloudy out, or I hope that's why. Yeah, I'm listening to see if I hear any monkeys out there. I was kind of psyched when I saw that monkey out at my corn feeder. But, I'm gonna start paying attention and see if I hear any monkey howls. So far, I just hear the hoot owls and the coons. All right, calibration is done. Don't know how good it's going to be. Time will tell. So I'm going to stop it for now, and let's get on over to target. So here's our target. We've got start guiding on, slew to target, center target. So when I push this button now, it's magically going to swing on over to the Oyster Nebula and start taking pictures. Now, again, I don't know if plate solving is going to work. I hope it does. If it works just even partially, then we can help it out as we need to go along. But let's find that out. So here we go. And there goes the telescope heading from Capella right over to the Oyster Nebula, like we told it to do. And you see it didn't have very far to go. So it's settling. Now it moved to 5 seconds finally. It's taking the 5-second plate solve image. There it is. Oh, and plate solving worked. Look there. It was not in the right spot, but that's okay. Plate solving worked, and it knows where to go. It made a quick readjustment. It's going to settle. Take another 5-second exposure. Plate solving, and I bet we're right on target this time. Okay, it thinks that we are on target. It's starting guiding, and it's going to start taking pictures. This is the plate solve image, starting guiding, and you see it's taking our first picture. Let's go back to the imaging tab and look at that. This is the 5-second plate solve picture that it took. And look right here in the middle. Do you see that kind of dim spot? Let me zoom that in. Look at there. There it is right there, the Oyster Nebula. So plate solving did work. It put us right dead on target. And you can already see some of it. Here's the progenitor right here, that star that exploded off its atmosphere, exposing the core. So this is the hot radioactive core of the star, and it's just blasting its atmosphere that it ejected, and ionizing it and causing it to glow. And that's what makes this nebula that we're looking at. Anyhow, there it is right there. That's just the 5-second plate solve picture. I can't wait to look at our first 10-minute image. So I'll come back with you here in about 9 minutes, and we'll see what our first picture looks like. And I'll tell you, this will be first light at the native focal length of 2800 millimeters on this scope. So I'm a little nervous to say I don't know if I can handle that full focal length, but we're going to find out. Back with you in a few minutes.
Oh Lord, it's hard to be humble when you're perfect in every way.
I'm getting a phone call.
I can't wait to look in the mirror, 'cause I get better looking each day.
Let me answer this phone call.
To know me is to love. I must be a hell of a man.
Hello? All right. That was my mother. She wants to know if I got my equipment running. Told her I did. Something is down there at the feeder right now. You hear the dogs going nuts. All right, here comes our picture, our first 10-minute hydrogen picture in 8 seconds. Let's watch it coming in right about now. Our first light at native focal length. And there it is. How about that? How about that? There it is, the Oyster Nebula. Let's zoom in there and take a peek. Yeah, I like that. There's some good detail in there. We're getting some birdie defined edges. You can definitely tell that it's an ellipse. And looky here, we're seeing some of those bubbles that provide detail to the, it looks like it's the interior, but I think it's actually on the exterior of the shell that this star made when it blew off its atmosphere. Anyhow, look at that detail. I got to tell you that I'm pretty happy with this. So let's see how the night goes. I hope the rest of them are this good or better. There's something. What's going on here? I'm not sure what that is, but I bet whatever that is will not be there in future pictures. Some aberration or something. There it is, the Oyster Nebula. And you see, even at the native focal length of 2,800 millimeters, it's just pretty small in the center there. If you're using a smaller telescope, a smaller focal length, I don't know. It might be hard to get any or much definition on this, but we'll see what we get. All right, now I'm curious to see what the next one is going to look like. Now look at here. You remember that weird stuff that was on the first picture? I said I thought it was going to go away. Well, there it is. It's gone away. Let me call the first one back up so you can remember what I'm talking about. See this weird stuff right here? Right there. And if we look in the second picture, see, it's gone. So I don't know what that was. Maybe it was a gamma ray or some kind of space radiation that impacted on the camera sensor. That's what I suspect it was. But it was an artifact that was there only in the first picture, but not in the second one. Interesting. All right, let's watch our first 10-minute oxygen exposure come in. Here it is coming in at about, what's that, about 1 minute. About 1 minute it's coming in. Let's watch it come in. All right, sped up time about 10 seconds. I'm not sure what to expect, but this object is blue when you see other pictures, so I'm expecting a strong oxygen signal. We're about to find out here in about right now. Let's watch it come in. There it is. How about that? How about that? That to me, that was even brighter than the hydrogen filter. Let's zoom in and take a peek. Yeah, you can see the same kind of detail in there as you can. So I think we got about the same detail as we got on the hydrogen filter, but this one was a little bit brighter. You could tell when it came in, it was a little brighter than hydrogen. So that's unusual, but kind of expecting it, because like I said, when you see other pictures on the internet and stuff, it does look blue. So there it is, the first oxygen image of the night. All right, there go the dogs. There's some coons back there fighting. There's a coon fight going on. The dogs heard it. They're going back there to check it out. Anyhow, 5 more seconds until our next O3 image comes in. Let's watch it come in together. Our next O3. And there it is. Looks just like the last one. So I don't know. This guiding is questionable. Maybe it'll get better. Maybe I'm dealing with some high clouds. I don't know. But like always, time will tell. So I'll tell you what I'm going to do. Unless I hear a monkey, or unless anything else strange or weird happens, then I'm going to let it run. I will collect the data. I will do my best shot to make a picture, and I will see you at the end.